Welcome everyone. I am Mohammad Saif and I will be giving a presentation on Ethereum 2.0. So to start the topic, let's have a little discussion about the background of Ethereum. Now Ethereum is the second largest cryptocurrency by market capitalization and the most popular blockchain network smart contract enabled platform. In the second quarter of 2020, the total transaction volume on the Ethereum network reached an all-time high of US dollars 14.3 billion, with 768 active DApps and 1.51 million users. This rapid growth in DApp usage recently has been driven by the rapid rise of decentralized finance or DeFi. Now, this extreme popularity, however, comes at the cost of ever increasing transaction fees or gas prices as they are known in the world of Ethereum. Based on gas price data, average gas prices have gone up by over 400% in as little as a few months. This means a simple token transfer using 21,000 gas could cost $0.05 on average, while a more complex transaction, such as using a decentralized exchange, could cost as much as $15 to $20. Now, on our screen, we can see the 90-day rolling average gas price, and as we can see that it has started to take a more exponential growth pattern. Now, moving on to the problems that we have. Now, Ethereum's founder, Vitalik Buterin, recognized a problem from the early on. They noticed that there are several trade offs when choosing between scalability, security, and decentralization, and where two can be satisfying all three is very difficult. This concept is called the scalability trilemma. Now, Ethereum 1.0 had security and decentralization as its main design axioms, and as a result, scalability was sacrificed. Now, the scalability trilemma, as we know it, is only an observation. It's not a really formal mathematical proof. Decentralization in this trilemma refers to the degree of diversification in ownership, influence, and value in the blockchain. Cryptocurrencies are in general decentralized since there is no single party that can govern the whole network. Decentralization is more of a spectrum instead of a binary yes or no, as we have seen different levels of decentralization in various projects like Bitcoin, Ethereum, Ripple, EOS, etc. Now, security refers to the level of defensibility blockchain has against attacks from external sources, as well as the resistance of the system to tampering. There are many attack vectors in blockchain system, including double spending attack, Sybil attack, DDoS attack, 51% attack, etc. Now, in general, more freedom, that is, free entrance slash exit of the network, results in higher decentralization but lower security, since it is harder to verify the identity for the new participants, where they can be owned by a single malicious entity or collude together to cause harm to the network. Scalability determines the capacity of the network, including the number of nodes in the network, the number of transactions that the network can process, how fast the network can process, and so on. Now, moving on to the main features that Ethereum 2.0 brings with it. Ethereum 2.0, like at 2.0, attempts to make Ethereum much more scalable and efficient while retaining or even improving its security and decentralization. We have a new concept which is known as the proof of stake, whereas earlier we used a concept known as proof of work. Now, proof of stake will make the entire network more energy efficient and decentralized, while the other new concept, sharding, will vastly improve scalability and throughput. Proof of work and proof of stake, the two primary consensus algorithms used by cryptocurrencies. Proof of work uses computationally intensive calculations in cryptography to ensure that only real transactions are validated, which is the algorithm behind Bitcoin and Ethereum 1.0. Every time a transaction is broadcasted to a proof of work network, miners race to solve a cryptographic puzzle to generate a hash which can be used by other miners in the network to verify that the transaction is valid. Once a hash has been generated, the new block is added to the existing blockchain, and this updated distributed across the network, becoming part of the canonical ledger. The first miner to generate the hash receives rewards in the form of the blockchain's native cryptocurrency. Now, while proof of work has been successful at securing the state of many blockchains, the computationally intensive nature makes it very energy inefficient and expensive to run. Proof of stake is a much more energy efficient and environmentally friendly process than proof of work. The staked collateral replaces the energy intensive process as a disincentive to protect the network from attack. Because of the lack of energy consumption on the part of validators, the rewards do not need to be as high as in proof of stake systems as in proof of work systems. Now, proof of stake networks, on the other hand, relies on validators to stake large amount of assets on the network before they are able to partake in transaction validation and claim rewards for doing so. Now, this collateral at risk makes it such that if a validator acts dishonestly, the assets can be taken away by the network. Instead of competing on speed and energy to generate a hash, validators in POS systems compete on the amount of collateral staked. The economics in POS systems must be well designed to ensure that the validator nodes are sufficiently incentivized to perform the work that secures the network. Now, this leads to something known as the nothing at stake problem. Now, typically, only one block will be presented to validators at any time, so there will be no dispute over which block is valid. However, during times of high network traffic, multiple blocks may appear simultaneously. As a result, it is in validators' economic interest to participate in every fork, since they can earn rewards on whichever fork ends up winning. As a result, consensus could be difficult to build, leading the network vulnerable to double spending attacks. Now, as is shown in the diagram, there are two scenarios. The first shows an ideal scenario of how the network handles forks, and the second shows how the network, under the nothing at stake problem, would proceed in case of a fork. As you can see, no consensus is reached and the network is in disarray, since there are two valid forks proceeding simultaneously. Now, at 2.0's implementation of proof of stake eliminates the problem of nothing at stake by using a simple solution to make the blockchain aware of other forks that are present and which validators are voting on which blocks. If a validator is caught participating in more than one chain, that validator's staked ether will be slashed as a penalty. Now, what are the benefits of the proof of stake system? First of all, it's energy efficient. Proof of stake systems do not require the consumption of large amount of electricity to secure the network. It will also lead to lower token inflation because validators do not have to spend money on electricity. Fewer new tokens need to be minted to reward validators also. How it can reduce centralization is that in proof of work, economies of scale make it such that miners with the biggest pool of mining hardware will win a disproportionate amount of rewards, which over time leads to centralization in mining pools. In proof of stake, however, rewards are distributed proportionately due to the nature of the voting system, which means that each validator's returns will be the same in percentage terms and no benefit can be gained by staking more. Now, the network also confiscates the collateral of attackers, while in proof of work, only energy is lost in attempting an attack. Now, let's discuss about Casper. For ETH 2.0, the proof of stake system is called Casper. Now, to begin with, time in ETH 2.0 is split into epochs and slots. Each slot is 12 seconds and an epoch is 32 slots, that is 6.4 minutes. Now, ETH 2.0 will have a minimum validator count of 16,384, who must each stake 32 ETH. The reason for this number is to prevent committees from becoming corrupted by potential attackers. Now, validators must also vote in a two-thirds majority to finalize blocks. after which nothing can be done to revert the chain to an earlier state. Now let's discuss the other feature that is being implemented in Ethereum 2.0. Now currently, the Ethereum network can only process around 10 transactions per second, which is a severe limitation when network traffic is high. Since transaction fees are also prohibitively high, the main reason for this low throughput is that every node must process every transaction. While this does improve the security and finality of the entire blockchain, it comes at the cost of speed. Sharding is the scaling solution chosen by the Ethereum community as the best option to achieve long term and massively increased scalability by removing the need for every node to verify every transaction. In the most basic form of sharding, the network is split into multiple blockchains that run separately and with each shard having its own set of validators and transaction history. Now, at 2.0, we'll split the network into 64 shards, with each shard being able to handle as much traffic as the current Ethereum network. Now, Ethereum will not achieve full functionality unless shards can communicate with one another. It would be useful if each shard operated completely independently of other shards. Now, as we can see in the diagram, at the center of the network will be the beacon chain, which is responsible for coordinating validator activities and, more importantly, to store information about state changes in all other shards. A randomly selected committee of minimum 128 validators will be assigned to attest to each block in a shard chain. Now, once this happens, a cross link can be formed between the beacon chain and then uh, crosslink can be formed and the beacon chain can then be updated about the status of shards. Now, as blocks become finalized on the beacon chain, the corresponding shard blocks will also be finalized. Now, let's discuss about the rollout phase. Now, although ETH 2.0 has launched its public testnet already, the fully functional version of Ethereum with DApp functionality and sharding won't be live in such a quick time. Now, instead, ETH 2.0 will be launched in phases since replacing the widely used Ethereum blockchain is a complex process that must be managed carefully. Now, phase 0 will implement the beacon chain, which will serve as the central backbone of the entire network, managing proof of stake for itself and all of the shard chains. In phase 0, ETH 2.0 will not be able to support smart contracts and dApps. In fact, its functionality will be to establish transfers of ETH from Ethereum 1.0 chain and to test the proof of stake system that it is working as it was intended. Now, in phase one, after the beacon chain is established and deemed to be working as intended, phase one will implement sharding. 64 shard chains will be established, and the beacon chain will begin organizing validators into committees to validate transactions on each separate shard in each slot and epoch. Phase 1 is primarily concerned with testing the mechanics of sharding and will not deal with account balances. Instead, the beacon chain will treat shard chain blocks as simple collections of bits with no structure or meaning. Until phase 2, no smart contract functionality or dApps will be able to run on ETH 2.0. Phase 2 is when the functionality of the entire network will come together, allowing dApps to be deployed. A new and upgraded virtual machine called Ethereum WebAssembly will also be introduced. Now, this assembly is similar in functionality to today's Ethereum virtual machine. It will be able to support account balances, smart contracts, and so on. One major upgrade anticipated with this is that developers will be able to deploy dApps coded in any programming language and not just in Solidity. Now let's discuss about the economics of ETH 2.0. Now, becoming a validator is pretty easy. Anyone with 32 ETH can become a validator once phase 0 is officially started, which it has. Now, the staking economics is really important because this is the thing which will disincentivize attacks on the network. Now, ETH 2.0 upgrade will bring switch from proof of work to proof of stake. This means that instead of miners competing for a block reward, validators will be paid to perform assigned rules and secure the network. As a result, it is extremely important to strike a balance in validator incentives to ensure the security of the network. If the incentive to stake is too low, the network will not reach the minimum number of validators needed to maintain cross shard consensus. If the incentive is too high, the network is overpaying for security and inflating at a rate that is detrimental to the economics of the network and other token holders. Now, rewards for ETH 2.2 validators will vary based on the amount of ETH staked at any point in time. If the ETH staked is low, the return rate per validator increases to incentivize additional validators to join the system. Similarly, as the amount of assets staked by validators increases, the rewards also decrease. This schedule on the screen shows the returns that can be earned by stakers at various validator pool sizes. The numbers that are given on the screen can also be reduced by a few other methods. For example, validators going offline will incur penalties to the rewards, and if 33% go offline at once, this leads to finality leaking. That is, where block finality cannot be reached due to a lack of two-thirds supermajority, and additional penalties for offline validators are imposed. Now, validators getting stakes slashed due to malicious behavior will also happen. So, using these two methods, we might also be able to reduce the rewards that are given. Now, coming to the risk and the costs that are associated with staking. The first being the computing and the maintenance cost. Now, users will need to run a validator client and beacon node. This will require at least a Raspberry Pi 4 or a low specification PC. In addition to electricity costs, user will also have to bear the cost of broadband internet. Now, this as a whole is not very much. The capital acquisition and lockup, user will need to acquire and stake the 32 ETH in the deposit contract, which will be logged in phase 0 until phase 1 is launched. There is also code risk. There are risks of staking software failure or security vulnerabilities that can result in loss of funds. And in additional to that, there's another risk, also the security risk. Users are responsible for the security of their own validator clients. If their client is hacked due to a security failure, there is no way to recover funds. Now, to discuss about the current status, while it has been in research and development since 2014, Ethereum 2.0 has actually been making some headway. Now, in December of 2020, the beacon chain went live as expected, which introduced the staking concept. However, the beacon chain can't really be used until the other parts of the transition go live. Hence, it is called phase 0 of the plan. The next phase will be merging the beacon chain into the current Ethereum blockchain network known as the mainnet. When this happens, mining Ethereum tokens will officially end and staking will become the primary way to create new tokens. This is supposed to happen in 2021, but it might not happen this year also. When it does happen, the beacon chain will have full functionality. The last part of the transition, which is expected to be rolled out in multiple phases, is the adding of the shard chains to give the Ethereum network more capacity to handle all of the demand and increase transactions per second. This is expected to happen sometime in this year also, but it's not really known when. Since the previous phase has been delayed, this might also be delayed. The launch of the beacon chain did represent a major milestone, and the Ethereum developers do seem to be really motivated and on their way to completing the full transition. But it has been a long road, and there is still a good deal of uncertainty around the timing. Now, just to summarize what we have discussed so far, a few key takeaways will I will now proceed with. Now, the two main features that are being implemented in it 2.2 are the proof of stake and sharding, and this is supposed to improve the security and the scalability of the network. Now, proof of stake is a much more efficient and arguably fairer method to distribute transaction validation responsibilities and rewards versus the proof of work, which was the original system, which disproportionately rewards large miners and consumes a lot of amount of energy on wasteful calculations to secure the network. Now, sharding, although complex, is one of the most promising methods to add scalability to a blockchain network, and in tandem with layer 2 scaling solutions, which can increase scalability by a factor of hundreds, if not thousands. Validator returns can range from 2% to 20% depending on the number of validators participating in the network. But returns will likely be on the higher end at launch and might not be so at the end. So, with that, I conclude my presentation of on Ethereum 2.0, and I hope you guys liked it. Thank you.